Hello everyone. In this lecture, we will discuss 80386 DX signals, bus cycles, 80387 coprocessor and microprocessor lab programming. So, we will start from the 80386 DX signal. That topic we have discussed also in first unit, the pin diagram of 80386. In last lecture, we discussed about the initialization procedure of the software of the protected mode and what is virtual mode. What is the difference between virtual mode, real mode and protected mode, and how processor switch between protected mode and virtual mode. So these conditions we have discussed in last lecture. Now we will discuss the 80386 DX signals. Then part 1 contain 80386 DX signals and 80386 DX bus cycle, and part 2 contain 80387 and DP. So 80386 DX signal again contain signal diagram and description of the signal. So in the first part again we divided into two part, signal diagram and description of the signals, and 80386 bus cycles divided into three parts: system clock, bus state and pipeline and non-pipeline bus cycle. So description of the signal. So before starting the description, we first have to remember or notice these things. Has represent the low active signal, I represent the input signal, O represent the output signal, I/O represent the input and output signal, and dash represent the no electrical connection. So this is the functional signal group, or we can say that this is the pin diagram of 80386. The pin diagram of 80386 and 80387 are same. We have discussed this thing also in previous lectures, that both this diagram contain the both functionality of 80386 and 80387. So first we have to understand, before starting the pin description of the 80386 or 80387 pin diagram, first we have to understand the some common terms like what is address bus, what is data bus. So what is address bus? Address bus basically we are using to transfer the data between devices. The devices are identified the hardware address of the physical memory. The address is stored in the form of binary numbers to enable the data bus to access memory storage. So in a small definition, if we convert into the small definition, so we can say that what is the address bus? Address bus basically used to transfer the data between devices. And what is data bus? A data bus is a communication device that transfer data between components of a computer or between computers. So basically data bus we are using for transferring the data between the component of a computer, means within a computer or between the computer. So data bus basically we are using for this thing, and buses is nothing but a group of wires that we are using for different type of functionalities like address bus, control bus and data bus. So now we will start the description of 80386 pin diagram. So 80386 DX is packaged in a 132 pin PGA. 80386 DX address 4 GB of memory through 32-bit data bus and 32-bit address bus. So we study this thing into the features of 80386. 80386 have a 32-bit data bus and 32-bit address bus, and physical memory is 4 GB. Okay, then address bus basically you can see in this pin diagram, address bus A2 to A31. So A2 to A31, you can see here this thing A2 to A31. So this is the address bus. So A2 to A31 address bus connection addresses any of the 4 GB memory location in the 80386 memory system. So A0 to A1 and A0 to A1 are encoded in the bus enable BE0 to BE3 to select any of the 4 bytes in a 32-bit wide memory location. So basically A2 to A31 address bus we are using for the connection addresses any of the 4 GB memory location, and A0 to A31 we are using for BE0 to BE3. These bus enable connections. So we are using A0 to A31 for the byte enable or bus enable for BE0 to BE3, because we know this thing 80386 is a 32-bit processor. So we can transfer the data, like 8-bit data you can transfer at a time, 16-bit data you can transfer at a time, 32-bit data transfer you can transfer at a time. So for this thing we are using a address bus from A0 to A1. For this thing means how many lines you are selected for transferring the data. And what is BE0 to BE3? BE0 to BE3, we can say that it is a bank enable signal, it is a bus enable signal, or it is a byte enable signal. So you can say anything: bus enable, byte enable, or bank enable signal. So these signals select the access of a byte, word, or double word. Means you wanted to transfer a byte, you wanted to transfer a word, or you wanted to transfer a double word. According to that, you select these byte enable signal or bank enable signals. So these signals are generated internally by the microprocessor from address A1 and A0. So A1 and A0, basically these address lines we are using to select the signal from B0 to B3. The 32-bit data bus supported by 80386 and the memory system of 80386 can be viewed as a 4-byte wide memory access mechanism. So the 4-byte enable lines B0 to B3 may be used for enabling these 4 blanks using these 4 enable signal lines. The CPU may transfer 1 byte, 2 byte, 3 byte and 4 byte by using the bus enable lines. Now, next one is the data bus. Data bus you can see here. This is the data bus. You can see here this is the 32-bit data bus from D0 to D31. So data bus connection transfer data between microprocessor and its memory and input output system. So these 32 lines act as a bidirectional data bus during different access cycle. So basically we can say that data bus we are using for transferring the data between the devices. Your next pin is a memory input output pin. You can see here this is a memory input output pin. So basically this is the output pin that differentiate between memory and input output cycle. So this pin select a memory device when at set to logic 1 or input output devices when it is set to logic 0. So here you can see also M/IO hash. So hash signal we are using for the hash signal basically indicate the low active signal. So whenever the logic this signal is set to 1, in that case it represents the memory cycle, and whenever this signal is set to 0, in that case it represents the input output devices. So once again we repeat this thing, memory input output signal. So this output pin differentiate between memory and input output cycle. So this pin select a memory device when at logic 1 and input output device in case of logic 0. Your next pin is a read write pin, W/R hash pin. You can see here this pin is your W/R hash pin. So this pin distinguish read and write cycle. It indicates that the current bus cycle is a write when at logic 1 and read when at logic 0. So you can see here again by the description of the pin W/R hash. If it is set to logic 1, so it represents the write cycle. If it is set to logic 0, so it represents the read cycle. Next pin is data control pin. Data control pin basically distinguishes data transfer cycle from the machine control cycle. So it indicates that the data bus contain data for or from memory of input output when at logic 0 or at logic 1 and or at logic 0 processor is halted or execute an interrupt acknowledged. So basically we can say that it working as a data pin when it's set to logic 1, or it behave like a control pin when it is set to logic 0. Then your next pin is a lock pin. So this pin enables the CPU from preventing other bus master from gaining control of the system bus. So basically this pin indicate right now your buses are busy to executing some task, so you cannot access the buses for the next cycle. So lock pin basically indicate you cannot gaining the access on of the system bus. Then your next pin is ADS pin. ADS pin you can see here. This is your ADS pin. So ADS pin full form is a address data stroke pin. So this address status output pin indicate that the address bus and bus cycle definition pin are carrying the respective valid signal. Means if it is related to read-write memory, whether it is related to data control, whether it is related to memory input output, in these cases these pins are carry a valid signal. Then your next pin is NA pin. NA is the next address pin. So next address calls the 80386 to output the address of the next instruction or data in current bus cycle. Means next address pin indicate the pipelining method. Right now your processor is executing some task, your current task is not complete, and in that case during the execution of the current task you are fetching the address of the next instruction. So any pin if it is enabled, in that case you can fetch the address of the next instruction, and this thing happen into the pipelining system. Now your next pin is a BS16 pin, bus size 16. So bus size 16 pin select either a 32-bit data bus cycle or it is a 16-bit data bus cycle. So if the BS16 pin is set to 1, in that case it select the 32-bit data bus cycle. If it is select to 0, it behave like a 16-bit data bus cycle. Your next pin is ready pin. Ready pin basically the ready signal indicate to the CPU that the previous bus cycle has terminated and the buses is ready for the next cycle. Ready pin indicate means it is opposite to the lock pin. Lock pin indicate right now the buses are busy and you cannot access any bus, you cannot raise a request for the buses. And ready pin basically behave like your current processing cycle is completed and now you can request for the buses for the next cycle. So ready pin basically what indicate? The ready signal indicate to the CPU that the previous bus cycle has terminated and the bus is ready for the next cycle. Your next pin is the interrupt pin, and we say interrupt is the INTR, NMI and reset. These three pin basically behave like a interrupt pin, and we have discussed in the previous lecture what is interrupt. Interrupt is nothing but a signal to the processor emitted by the hardware or software indicating an event that needs immediate attention. Means your processor is executing some task and during the execution if the interrupt is generated, so basically it identified by the processor it is a non-maskable interrupt or maskable interrupt, and according to that the processor execute the interrupt process. So interrupt is nothing but the we can say that these are the process or higher priority process to indicate the processor that gain the access of the processor basically during the execution of some cycle. So interrupt is nothing but a signal to the processor emitted by the hardware or software indicating an event that needs immediate attention. Then INTR pin. So in an interrupt basically we are using a 3 pin, INTR, NMI and reset pin. INTR, first we discuss the INTR pin. Interrupt request pin. So an interrupt request is used by the external circuitry to request an interrupt. So this is a maskable interrupt pin that can mask using the IF bit of the flag register. So basically this is the external interrupt pin and it is enable, or basically we can say that it is depend on the interrupt flag bit that reside into the flag register. If your IF bit is set to 1, in that case this pin this pin will be enabled, otherwise it will be disabled. Your next pin is a non-maskable interrupt pin. So whenever your non-maskable interrupt is generated, it's signaled by the NMI pin. And next pin is a reset pin. So reset, a high at this input pin suspend the current operation and restart the execution from the starting location. So again it is an interrupt pin. Whenever this pin is set to high, in that case your processor will stop suddenly all the execution and restart from the starting location. Next pin is your hold pin. You can see here, this is your hold and hold pin, and these are your interrupt pin, INTR, NMI and reset pin. So what is the functionality of hold pin? So the bus hold input pin enable the other bus master to gain control of the system bus if it is asserted. Means you can raise a request for the buses. And hold acknowledgement pin, what is the functionality of this pin? Hold A pin means hold acknowledgement pin indicate that the 80386 currently in hold and it on. Means you can, if it is accepted by the processor to release the buses, so in that case it reply by the hold A pin. Your next pin is a busy pin. You can see this pin here in the pin diagram, busy pin and error pin. So busy pin, basically the busy pin input signal indicate to the CPU that the coprocessor is busy with the allocated task, and error pin indicate to the microprocessor that an error is detected by the coprocessor while executing an instruction. So basically busy pin indicate that the coprocessor is busy in the allocated task, and error pin indicate that coprocessor detect an error during the execution of the instruction. And next pin is a PEREQ pin, processor request extension pin. So the coprocessor request asks the 80386 to relinquish control and is direct connection to the 80387 arithmetic coprocessor. Then next one is the clock pin, CLK2 pin. So this is your CLK2 pin, clock pin. Clock pin provide basic system clock timing for the operation of the 80386. So basically it is provide the just clock timing for the operation of 80386 processor. And VCC, these are VCC and ground pin. So basically these are the power supply pins. VCC is a power supply pin and ground is the related to the ground. So these are basically two pins related to the power connection. Okay, so this is a pin diagram of 80386. Also we are studied this diagram into the 80387. Thank you. Further we will discuss into next lecture.